This video looks at the cross product, which is another operation that we can do between two vectors that produces a third vector which is perpendicular to the plane in which the first two vectors lie. So if you have A and B, which are in the same plane, and there's some angle between them, performing the cross product produces a third vector, which is perpendicular to that plane. So vectors have a magnitude and a direction, and so the direction of C, the vector created by doing the cross product between A and B, depends on the right-hand rule. So the right-hand rule states that when the fingers of the right hand point in the direction of A and curl toward B, the thumb points in the direction of A cross B. So I will link a YouTube video on Google Classroom that shows you an example of the right-hand rule in live action. So the magnitude of A and B is equal to the area of the parallelogram determined by the vectors A and B. So if we remember, so the area of a parallelogram is equal to the base times the height. So here, so I'm going to draw my parallelogram here. So I've got A this way, B this way, and then I've got the rest of my parallelogram here. And then this angle, or this part right here, this would be my height. Okay. Now my base, as you can probably see, this would be the magnitude of A, and my height would actually be B sine theta, using my primary trig ratios on this right-angled triangle that I've highlighted here. So this is our expression for the cross product of A and B. So we can say that A cross B is equal to, or the magnitude is U times V sine theta, based on this connection to the area of the parallelogram. So let's look at an example. If the magnitude of U is 4 and the magnitude of V is 10, and the angle between the two is 60 degrees, find the magnitude of U cross V. So to do that, we're going to set up our expression. So the magnitude of U cross V is equal to the magnitude of U times the magnitude of V sine theta. We have all the information that we need. So 4 times 10 sine 60. 40. Sine 60 is a special triangle, so this simplifies to root 3 over 2, which gets us to 20 root 3. So next example, instead of being given the actual size of the vectors, we're going to have Cartesian vectors, so denoted by vector A is A1, A2, A3, and then vector B is B1, B2, B3. So the cross product is actually A2, B3 minus B2, A3 is the first coordinate. Then we've got A3, B1 minus B3, A1, and then the last coordinate is A1, B2 minus B1, A2. So we can, the cross product between two vectors gives us a third vector. So this is kind of complicated, but it's a process that you should memorize. And we're going to do a strategy here that's going to help. So list the components of vector A in column form on the left side, starting with A2, and then A3, and then A1, and then A2 below each other. So we'll start with that. So we've got A2, A3, A1, and then back to A2. B, we're going to do the same thing. So B2, B3, B1, and then B2. So our first coordinate, I'm going to do in green, is going to be the first set of 4 multiplied diagonally across and then subtracted from each other. So A2, B3 minus B2, A3. Our second one, I'm going to highlight in red here. So we've got A3, B1 minus A1, B3. Finally, the third one, I'll do in blue. We've got A1, B2 minus A2, B1. Okay, so let's do an example with real numbers down here. So we're going to set up our vector A and our vector B, starting with the second coordinate in each. So second coordinate, third coordinate, first coordinate, second coordinate. Same thing for B. Second coordinate, third coordinate, first coordinate, and then second coordinate here. Okay, then we're going to multiply them out. So I'll try and use the same colors that I did before. So our first coordinate is 2 times minus 4, take away minus 3 times 1. Then in red, we've got minus 3 times 5, minus 6 times minus 4. And then our last one in blue, 6 times 1 minus 2 times 5. Now, it's important to make sure that you've got the correct signs, because sometimes you'll be subtracting a negative, and you want to make sure that you're subtracting the appropriate one. So when you do those coordinates, okay, you should get, let's write them out first. So we should get, let's see, 8 minus 3. Next one in red, minus 15 minus 24. And last one in blue should be 6 minus 10. So ultimately, when you simplify, you will get A cross B is equal to 11, 9, and then 16. The cool thing is if you reverse it, you actually get the negative. Okay, which means that your vector C that's created is actually in the opposite direction, which makes sense when you think about how you get the direction using the right-hand rule. Let's try another one. Determine the area of the parallelogram determined by the vectors P, minus 1, 5, 6, and Q, 2, 3, minus 1. So the area of the parallelogram is going to be the magnitude of the vector P cross Q. So the first thing that you need to do is find out what the vector P cross Q actually is. So let's start. I'm going to write out P, starting with the second coordinate, third coordinate, first coordinate, second, and Q. And I'm going to get 3, minus 1, 2, and then 3. And then I'm going to do, I'll use my colors again here. Let's start with green. So my first coordinate would be 5 times minus 1 minus 6 times 3, which should give me minus 23. The second one I will do in red, 6 times 2 minus 1 times minus 1, which should give me 11. And then the third one in blue would be minus 1 times 3 minus 5 times 2, which should give me minus 13. So now I have the vector, but I'm asked to find the area. So in order to do that, I actually need to find the magnitude of the vector P cross Q. In order to find the magnitude, hopefully you remember this from last year, we are going to square each component add them together and then take the square root. So we've got minus 23 squared plus 11 squared plus minus 13 squared, and then square rooted. And so when you do that, you get the root of 819, which means that our area of the parallelogram is approximately 28.6 units squared. Okay, one more example. Here we're going to determine the area of a triangle formed by the points A, B, and C. So now what we need is the area of the triangle. So you probably remember that the area of a triangle is going to be 1/2 of the area of a parallelogram created by those same 3 points. So we're going to create 3 position vectors. Again, hopefully you remember this from last year. If you don't, that's okay. Position vector is just from the origin to the point. So we have OA, OB, and OC. Okay, so now we're going to create the vectors that make up our triangle, ABC. So we've got the vector AB, which would be the position vector OB, take away the position vector OA, and this would give us 0, -2, -1. Then we'd have the position vector AC, which would be OC minus OA. And here this is going to give us 4, -3, 3. So now we've created, if I just draw off to the side here, we've got A, B, and then we've got AC. So 2 sides of our triangle. As you can see, if I were to extend this, imagine that that is a parallelogram. Let's try that again. The area of my triangle would just be 1/2 of that parallelogram. So then what I need to do is AB cross AC, and then eventually I'm going to divide it by 2. So if I'm going to cross them, I'm going to write out my coordinates, starting with the second one. So -2, -1, 0, -2. Same thing for AC, 3, -3. And then I'm going to cross them. So again, I'll start with red. So we've got -2 times 3 minus -1 times -3, which should end up giving us -9. Second one, in green, we do -1 times 4 minus 0 times 3, which should give us -4. And our last one, in blue, we do 0 times -3 minus -2 times 4, which would give us 8. Next, we need to find the magnitude. So I'll do it here. So we've got, let's write this out all in one step. So we would have our area of our triangle is going to be the magnitude of AB cross AC all over 2. So for our magnitude, same as we did before, we're going to square root the sum of the squares of the components of the vector, like this. And then we're going to divide by 2 because we're only looking for a triangle. When you sort this out with your calculator, you'll get that approximately the area of your triangle is 6.34 units squared. Those are some examples of how to perform the cross product and how to solve some basic application problems.